Okay, thank you very much for this gathering and Hashi talk discussing all about technology. So my talk today, it's a short little discussion and current research work I'm doing. It's about addressing technical debts with the or using infrastructure as code, which is Terraform. And in this talk, I'm trying to discuss how to leverage infrastructure as code technologies, and there are many of them. Like, of course, Terraform is one of them, Pulumi, or even Tosca, which is originally supposed to orchestration. Industry is more now of the commercialized form. The Terraform is becoming so popular now. So I'm trying to discuss how it tackles the technical debts in software engineering. So my name is Mohammed Mubarkoot. I'm a PhD student at Seoul National University, and this is my the agenda I'm going through. So I will talk briefly, explain the laws of software evolution because this is the key problems which lead to software engineering workarounds. And after that, I will discuss the technical debts and how they arise, and then extend the extent to which the infrastructure as code can mitigate technical debts. Then we'll introduce the our proposed framework or approach, and how did we implement it and evaluate it. So generally speaking, there are forces that drives the progress of any innovations, and also there are other forces that slows down the progress. And when it comes to software, there are 8 laws that govern the development of software and evolution of the software. So when we talk about software here, we mean like E-type software. They're like S-type and E-type and P-type. So E-type, which is technically automate human and societal activities and involve more real-world problem solving. And this type of software evolves over time as a response to real-world changes. And accordingly, Lemons has introduced 8 laws that govern the evolution of the software, as you see in the figure. So, in his theory, Lemon argues that the software continues to grow and its size and complexity increases eventually, and in turn, its quality decreases. And this evolution is constrained by the need to maintain familiarity of users as well as organizational stability. And while the other forces, like a feedback system, continue to call for more improvements. So these forces that control how the software evolves and governed. So what are workarounds in software engineering? So when you say workarounds, it's a temporary fix of a problem or improvisation using alternative ways to perform the same task and gain some short-term benefits. This could be like time, mostly time, because in industry we have this time pressure mostly, or techno stress, or any other forces that demands us to buy some time or to achieve tasks within very time constraints. And workarounds are circumvention. It's like a tuning of a problem without eliminating it. As you can see in the figure here, we're not just following the steps that's supposed to go through and produce the quality that we are intended to achieve. Rather, we choose a shortcut and we try to do some trade-offs in order to deliver the feature or to make the application or the service running within the time and budget constraints. So the consequences, according to of the workaround, the technical debts, are every minute spent on not quite right code counts as interest or debt. So an example of workarounds, it's including skipping security configurations, proceeding with the default port numbers, monolithic application development and instead of modular one, and the documentation drifts that we have. Let's say something documented, but in the production environment is something missing there. So technical debts could be intentional or unintentional. And as a human being, also sometimes we just do mistakes or we are in a rush of meeting deadlines. It happens that the intentional technical debts are those that takes on consciously as a strategic tool, as opposed to unintentional debts. As you see in the figure here, the quadrants of the technical debts. So opposed to unintentional debts, we call non-strategic tool results of doing poor job. And if you see in the figure here, in the short run, we might gain something, more features within short time. But if we do a proper refactoring and produce a better quality code, in the long run, we'll have a proper development and we'll eliminate the dirty ways of doing things and do not accumulate these technical debts. So an example of technical debts could be architectural debts, security debts, documentation debts, infrastructure debts, and defects debts or process or requirements, the many forms of the technical debts. So how technical debts arise? And as we mentioned earlier, the software evolves as a result of real-world changes, and its size grows and complexity becomes more complex. And software engineering is one of the most stressful jobs due to many reasons. Among them is the overwhelming new technologies and tools. And we have like a bunch of technologies emerging like every 2-3 months, or let's say annually we have this new best practices introduced and we need to adapt them in order to keep up with the technological development. This high dynamicity of technology one side, security concerns also, and best practices are so on. And throughout that, engineers face pressure, complexity in some technologies. Also, we have this skill gap. Engineers like difficult or hard to maintain. So just find a better over they leave. We replace them with the new engineers. So they have to learn everything from scratch or at least cope up with the recent change that we're doing, besides the existing accumulation of technical debts or workarounds conducted. So this can also raise some skill gap, and in many cases, they have to deal with already existing workarounds. So this in turn can result in many forms of technical debts, as we say, like security debts, compliance debts, and documentation, environmental drifts, architecture, infrastructure, and it's basically how it starts, arise, and accumulate. So how can we leverage infrastructure as code to solve such issue? Technical debts mostly happen due to human errors at first. So with infrastructure as code, the infrastructure design, we can reduce human involvement and increase more automation. And for example, on the infrastructure design, provisioning, and management. Also, with the infrastructure as code, we can enforce some security best practices and hardening the configuration and therefore reduce any misconfiguration. And besides that, we can engage in different stakeholders in designing and validating the infrastructure because before making it available. So these stakeholders include compliance experts, IT managers, domain experts, software architects, and engineers. So it's easy to involve all stakeholders in the design of the blueprint. So with infrastructure as code, you can also reduce environmental and documentation drifts and ensure reproducibility of the same environment, because we want to make sure that the what's settings and the configuration, the production are the same. We're having it in the testing and staging environment. So more automation and also enhancing auditing and reporting. So this is a simplified version of the approach that we are proposing. The process started by designing the software blueprint with the concerned stakeholders. For example, you have the IT manager, the compliance experts, and software architects. Once the design is done by the stakeholders, the blueprint is validated and published into a repository to be made available for developers and operations team to use, and in a way that it allows continuous delivery and updating of the software features, because in recent days we have this software always in a releasable state, so the continuous addition and updating of these services is never stopping. So it's a continuous development and operations. So but any modification in the topology itself cannot happen unless it's approved and reviewed by all stakeholders, the concerned one, before proceeding or like publishing it to the repository and made available by DevOps teams. And finally, most important task is to execute the blueprint by the orchestrator, which in our case is Terraform. I will talk about the implementation of this, and conduct auditing and reporting on a regular basis. And the reporting can also be customized at the different levels of insights and abstraction, depending on stakeholders' involvement and responsibility in that entire ecosystem. So this is how we implemented the proposed approach. So we used Terraform is a one component. We used it as infrastructure as code engine, and we used ImmuDB to provide an immutable storage for publishing the IaC blueprints, so that we can keep track of them and maintain their versioning, and make sure that they're tamper proofing, and any changes happen in the blueprint should not be committed here unless it's reviewed and confirmed by all concerned stakeholders. So the next component for this framework is we used an automation using cron job. We built it from scratch, and the task of this cron job is to make sure that the repository that the blueprint that we designed and we make it active in the repository is exactly what is in the provisioning and testing and staging environments at our provider. And for the cloud provider, we used AWS because it's simple and straightforward. We considered in the beginning using alternative like OpenStack to have a full private, but it's still we are testing it. But for now, the AWS is doing great on integration of Terraform and the API and deployment of infrastructure as code. So with this entire ecosystem and framework, we make sure that all concerned stakeholders keep updated if anything or any mess up happening in the infrastructure in the provisioning environment, or there are some changes needed to be updated again. So let's say we propose some changes now, and the scheduler will confirm, oh, there's some changes happens. Do you guys want to confirm or not? Because there's some mismatch. And with this way, we make sure that DevOps engineers are not messing up with the configuration, and they're following what's exactly deployed for them as infrastructure to follow in the provisioning environment. So, and this is how we enforce the blueprint at all stages of the software development, development and testing and production environment. So we also consider using another alternative way of confirming that this approach or framework is can be utilized and can be very effective, because when you talk about technical debts, we cannot just evaluate it in a short run, because the accumulation of workaround happens in a little bit long run. So the experiment of this research will not, get what exactly the we cannot observe the technical debts and the workarounds arise as a consequences of this. But alternatively, we use another way of using a confirmatory focus group in order to prove that the artifact we're proposing is useful, and the utility we're having it there, and also it has the effectiveness and efficacy to pursue and address the technical debts. So we composed two focus groups. We call them confirmatory because this research belongs to design science, and we'll have like two kinds of focus group, either confirmatory for evaluating the utility and efficacy, and we consider many stakeholders to achieve this target. We have software architects, compliance experts, and IT managers. And also, we developed some metrics so that we can tell that our approach is valid or not valid based on these metrics of utility and efficacy. And in that, throughout the discussion of the focus group, we will collect evidence and counter evidence that support how useful is it, the artifact, how is easy to use, does it address, or to what extent it addresses the infrastructure debts, environmental drifts, security compliance debts, and overcoming documentation, and finally mitigation of workaround. And this is still work in progress. Hopefully we'll have um, some coming research soon, and we'll keep the community updated with this. With this, I would like to conclude my presentation today. And if you have any questions, please you can post them in the chat, and be happy to reply. And here are a list of references that we use. And thank you very much.